We're now moving on to part 2 of waves, and we're looking at the electromagnetic spectrum. You can see from the diagram that we have radio waves at one end of the spectrum, which have a very large wavelength, about the size of a building or a football pitch, or it could even be longer. It can be up to 1 kilometre in length, can the wavelength of a radio wave. And the gamma rays at the other end of the spectrum have a very small wavelength, about the size of an atomic nuclei. You can see that as the wavelength decreases, then the frequency of the wave increases. Now, electromagnetic waves are so called because they consist of both an electric wave and a magnetic wave, and these waves sit at right angles to each other, and they are in phase with each other. In other words, the crest of one coincides with the crest of the other, as do the troughs. Now, electromagnetic waves transport energy through empty space, and that energy is stored in the propagating electric and magnetic fields. And a single frequency electromagnetic wave will exhibit a sinusoidal variation of both its electric and magnetic fields in space. If we come back to the electromagnetic spectrum, you may wish to have a mnemonic to help you remember the order of the waves in it. And if you haven't got one, there's one shown there. And as the frequency of the wave increases, the energy carried by the wave also increases, which is why gamma rays are so dangerous. Now, these couple of slides show some tables which give you the properties of different waves. So you may get asked these in an exam. It's useful to study these tables and remember where the waves come from, an example of how you would detect it, an approximate wavelength for each of the waves, a typical use for each of the waves, and what happens if you are overexposed to them. You may wish to pause these slides to study these tables. And that is the end of part 2.
Created using Powtoon.